See, in this particular chart, I am trying to show the relationship between the decibel value in different suffix or different units. Suffix, you know what it is. Suffix is something which is fixed after something, right? So dB is a ratio. Ratio without a suffix is meaningless. Give me 10 bananas if I say. What is the meaning of it? Either 1, 0, 10 banana, 10 dozens banana can also be there, 10 kg banana also can be there. So just 10 will not mean anything. She is 11, it will not mean anything. Inches, feet, centimeter. Correct? Similarly, dB should always have a suffix because it's a ratio. Now here, as audiologists, what we see dB in or on is the audiogram. Right? This is the audiogram. And what happens? We see different decibel values on the y-axis. X-axis we have the frequency. You as first years, when you do your hearing test, have you seen that many of you have responses at 0 dB HL? 0 also you have. Some have minus also. So what, can you, if you are having a response at 0 dB, does it mean that you can hear silence too?
No, sir.
Then it means what?
0 has a value.
Has a value. Means 0 dB HL does not mean silence. Understood? Why? Because dB is a ratio, the reference which is taken is 10 to the power minus 12 watt per meter square. So that is the faintest amount of sound which can be heard by an individual in a particular frequency, not across. For example, in 125 Hertz, an individual can hear 45 dB SPL sounds. 45 dB SPL. But when we plot it on the audiogram, or when we have to give an input on the audiogram, then the measuring scale should be flat, no? It cannot be up and down. So here for each frequency, for example, we hear the loudest, means like you have to put in the loudest sound to be heard for 250 Hertz, 125 Hertz, still lower, that is 45 dB SPL. And if you see the lowest for 2 kilohertz. So that means our ear is most sensitive to which sound? 125 Hertz or 2 kilohertz? 2 kilohertz. That's why this minimal sound can also be heard. But when you plot it on an audiogram, or when you have to express it on an audiogram in terms of what? dBHL, then this particular reference is added. That means silence is not equivalent to 0 dB HL here, does not mean silence. And it is equal to X plus 0 dB SPL. Means like, let's say this amount of SPL value would be there in this 0. And this amount of value is what? It is the minimum threshold amount of sound which can be heard by a normal individual. So a group of 500 people we have seen. Okay, this is the amount of sound which a person can hear. This is the SPL sound. We put this much of sound at 125 Hertz, 0 dB HL. It will be fed in the audio meter. So the moment you hear it, then automatically that amount of sound will be coming at 0. So 0 dB is not silence, understood? So 0 dB HL concept. So here the rabbit is thinking, okay, these all carrots are looking alike from outside. So it's all 0 dB, no? But the rabbit is thinking, I don't know how big a carrot would be inside. So similarly, in an audiometer, across different frequencies, 125, 250, 500, 1K, 2K, 4K, 8K, the amount of reference sound which is in dB SPL would be different. And because our sense of hearing is best between 1 to 5 kilohertz, here you can see these require minimum amount of sounds. Clear? So 0 dB SPL and 0 dB HL relationship you understood?
Yes.
dB is a ratio you understood, without a suffix useless, understood? The third thing is the moment. There are many tests. For example, I want to do how comfortably you can hear sound with amplification, how effective a hearing aid would be. then the hearing aid should be fit at your most comfortable level. So it is always above the threshold. Understood? No. So if it is above the threshold, then we always give some intensity above the threshold. So that is referred to is in terms of what? SL. For example, if you have 0 dB thresholds on your audiograms, then we will say, okay, we will give you sound at 60 dB SL, which means 0 plus 60 dB. If you have threshold of 60 dB and I say I will give you sound at 60 dB SL, the sound intensity would be how much? 120, and 120 is what? Threshold of pain, right? So when you say SL, it always adds on to your threshold, correct? There would be another thing which is known as dB, NHL, ABR, gold standard. You give clicks, click, 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 click. It's a broad frequency spectrum. So to those clicks, when it is normalized, then the suffix which would be used is NHL. Correct? What else dB suffixes are there? You remember for anything? We talked about SPL, dBSPL, dBHL, dBNHL, dBSL. Anything else? dBA. Now, when you measure what is the amount of noise around you using a sound level meter, then it can measure flat everything as it is, or it can measure the way the ear hears it. The moment it uses a scale where it measures sounds how the ear hears it, because we are interested in hearing loss, no? How that particular noise would be affecting our ears. The suffix would be A, so it is dBA. When it measures everything equivalent, it will be dBC, correct? So these are different dB suffixes which are used, and I hope you understood this particular audiogram, the rabbit on it and the SPL values on it, correct? dB clear? Study more. Thank you.